Welcome to True Projects. In this video, we are going to explain about the project that is enhancing smishing detection, a deep learning approach for improved accuracy and reduced false positives. Before getting into the execution, first let us understand what is the project about. Here, we are living in an age where technology is growing like a crazy, right? Smartphones have made life so convenient that you can connect with anyone, anywhere, and anytime. But with all this benefits, we also have flip side too. Cyber threats they are on the rise, and one of the sneakiest one is called smishing. It is like phishing, but instead of email, attackers they use SMS to target people. The tricky part is that these messages they often look super genuine. They might pretend to be your bank or delivery service, tricking you to clicking on links or share the private information that your passwords or banking details. And because of SMS, you feel it urgent, like when you get a message and immediately you want to check it. People don't always stop to think it whether it is legitimate or not. This quick response is what these attackers rely on to pull off their scams. So, you know how most systems try to detect smishing using blocklist rules? Well, those methods have some big flaws. Blocklist, so these blocklists, for example, rely on database for known malicious URLs, but attackers are smart. They keep switching up their domains or use link shortening tools to hide the real link. This makes the blocklist pretty much useless against evolving threats. Then these heuristic approaches, which work by looking for certain patterns like suspicious words or URLs in a message. While that sounds good in theory, in practice it can be overly sensitive. Legitimate messages like a bank update or a promotional SMS can easily get flagged as smishing just because they happen to look a bit similar. So these methods end up generating a lot of false alarms, which is frustrating and inefficient too. Clearly, we need a smarter system, something more advanced than that can reliably tell that difference between safe and harmful messages. So, to overcome with all these issues, in this project, we are proposing a system that will combine two powerful deep learning models that are convolutional neural network and LSTM, that is long short term memory to detect smishing messages. So, here is how it works. CNN or convolutional neural network, it acts like a feature extractor. It can scan through the SMS text to pick up the important patterns like certain word combinations or structures and optimizes these features. Once CNN has done its job, the LSTM it takes over. That is long short term memory. LSTM is really good at understanding the context of the text, so it will understand the sequences and also context. So it processes the features from CNN in a way that captures the flow and meaning of the message. Together, this setup that is together combining convolutional neural network and LSTM, this setup ensures that system can accurately tell the difference between legitimate, that is ham, and smishing messages. Plus, because of the two techniques complement with each other, it reduces the chance of wrongly flagging legitimate text as smishing. And here is how the model trained. So we combine the data set from Kaggle and Mendeley, which includes SMS that are labeled as ham and smishing. Before feeding the text into the model, we clean it up to make sure that data is in a good shape. And this involves certain steps. So this involves removing unnecessary words, simplifying words, and getting rid of any special characters or numbers that don't add value to the model. And once the text is clean, we convert it into a format that the model can understand. So this is done using TF-IDF. It's a technique that turns the words in the SMS messages into the numeric vectors, capturing the importance of each word in the context of the message. These vectors are then used to train and test CNN LSTM model, helping it to learn how to distinguish between legitimate messages and smishing attempts accurately. To further improve the performance in this project, as an extension, we are combining CNN, LSTM, and bidirectional LSTM to take smishing detection to the next level. So the CNN is responsible for extracting and optimizing features from the SMS text, while LSTM it processes these features, helping the model to understand the sequence and context of the word. What makes this extension special is, in addition with this bidirectional LSTM is that unlike traditional LSTM, which only looks at the past context, the bidirectional LSTM, it looks at both past and also the future context. This gives a model fuller understanding of the message. This makes the system more accurate, improving its ability to detect smishing messages. And coming to the part of front end, additionally, we have created a user-friendly front end using Flask, which allows for secure interaction with the system. This front end ensures that only authorized users can test the system, keeping their data safe while making the system easy to use in scenarios. This setup not only improves the usability but also ensures that system can be tested in a secure and practical way. And coming to the implementation, we have followed the steps mentioned in the flow of work. So, first, what we have done is we have imported all the required libraries and packages such as pandas, numpy, scikit-learn, keras, flask, etc. And then we load the data set. In this step, the data set is loaded and explored to understand its structure, including the number of records, features, and class labels, along with identifying any missing or irrelevant data. And then comes data preparation. Here, commonly used words like the, is, in, that do not add meaningful information are removed from the text. That is called removing stop words. So we will be removing the words like the, is, in, etc. like that. And then comes removing special characters. Any non-alphanumeric characters like punctuations and symbols are eliminated to clean the text. And then comes stemming and lemmatization. Here words are reduced to their root forms. For example, if the word is running, it becomes run if you apply this stemming or lemmatization to standardize the text. And then comes feature extraction part. Here, TF-IDF, that is called Term Frequency Inverse Document Frequency technique, is used to convert text into numerical form. This highlights the important word while reducing the weight of common words. Coming to data standardization, data is standardized to ensure that features, that is word frequencies, are on a same scale, which helps to improve the model performance, especially for algorithms that are sensitive to input scale. Coming to label encoding, the categorical labels that are ham, smishing are converted into numerical values to make them compatible with the machine learning model. And then we split the data into train and test sets. Training set is used to train the model and test set is used to evaluate its performance on unseen data. And then we initialize the models here. We define the layers, we define the layers, activation functions, and also the other parameters for the model. And that initialized model is trained on the training data set where it learns the patterns in the data by adjusting its weights to minimize errors. And then all the models which are trained, they will be evaluated using precision recall FN score and accuracy to ensure that it can effectively classify SMS as legitimate or smishing. Coming to the front end part, as user interface is created using Flask to allow users to interact with the model, this includes features like registration, login, and connecting to a SQLite database to store user information securely. And in the front end, users they will be able to give the input, that too as a text. So users they will be able to give the input in a text format, and that will be pre-processed at the back end. It will be fed to the train model and that will be displayed in the front end, whether the given message is ham or a smishing message. Moving on to the algorithms used here in this project, we have used BiLSTM, GRU, LSTM, and this is a proposed model and this is the extension model combining CNN LSTM with the bidirectional LSTM. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software are application of Python, front-end framework Flask, back-end framework Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So these are the requirements, and this is the overview of the project. Now let's execute. To execute, we are supposed to open the code folder which contains source code files. Let us open the code folder. These are the source code files in the code folder of the project. Now let us understand each file, how will they be used in this project. Let us open the dataset folder. So these are the two datasets used in this project to train the models. So let's open them. So here is the target label, whether the given text is ham or smishing. And here we have the text, that is the message. And these are the other features. It is URL, email, or phone, whether it is sent as URL or it has been sent as email or it has been sent as phone. Now let's close this. Let us open this Kaggle smishing. So here this is the target label and here we have is the text. Let's close this. These two data sets are used to train the model for detecting smishing or ham message it is. And here in this test data file, we have test cases that we will be using in the front end for predicting whether a message is ham or smishing. Let's get back. And here in this model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files, and that will be loaded into the project code during runtime of the application. And the next folder is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And then we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have a app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. This is the signup.db file. This file is a database file which is used to store the user information. And this is the Jupyter notebook file, which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. So this is all about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. Now open the command prompt. It has been opened. Give the command cd, give the space, and paste the copied path. Now click on enter. So here if you observe, current directory is changed to the code folder's path by giving this command and giving the path, specifying the path. Now we are supposed to compile app.py file, that is the front end file. Give the command python space app.py and click on enter. So this app.py file command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework, it will host the application locally at the default address, which is the local host. This is the local host and the port unless configured differently. So we are supposed to copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Open the Google Chrome and paste the link. Click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So here you can see sign up, right? Click on that and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in and give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see choose file, right? We need to click on this button for uploading the test case file. So click on choose file. Let us upload this test data. Click on open. It has been loaded. Before uploading, let's see what do we have in that data. So let's open the data set and let's open this test data. So these are the different text messages that now we will be uploading. And now let's see what will be the prediction. Let's close this, get back to the application and now upload it. So this given input, it will be pre-processed at the backend and then train model will be giving us a prediction. So this is the first test case, first text that we have uploaded for the given test case. Here we got the prediction as smishing. So this message is a smishing message. That means a fraud message has been sent to the SMS. Similarly, for the second message, it has been predicted as ham. Ham means it is not a harmful, it is not a smishing message. It is a normal message. It's a genuine message. And for the next case here, we got the prediction as ham. Accordingly, for all the messages that we have given, we got ham and smishing. Whether if the message is smishing kind of message, we will be getting smishing. If it is ham, then we will be getting ham. Ham means it's a genuine message. Now let's check with the graphs. Click on graph. So here, first graph which we have is the extension models confusion matrix, that is CNN LSTM bidirectional LSTM graph. So this is the confusion matrix graph and this is the ROC AUC curve graph. Here on x-axis we have false positive rate and on y-axis we have true positive rate. And this is the accuracy comparison graph. So here in this graph, on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained for predicting the smishing messages. And here we have precision score comparison graph. This is the recall score, and here we have the FN score comparison graph. Now click on sign out. In this way, just by giving the text to the application, then application will predict whether it is smishing or ham. If the message is smishing, it will predict smishing. If the message is ham, it will predict it as ham. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.